Section 10.8 is on equations of circles. The equation of a circle is the quantity x minus h squared plus the quantity y minus k squared equals r squared, where the center is the point hk and the radius is r. So in this equation, x and y are going to stay x and y, h, k, and r will be numbers, and the point h, k is your center, and r is going to be your radius. So let's try a couple examples. For each of these, write the equation of the circle. So the circle has a center at the point 0, -1, and its radius is 8. So let's go ahead and label those points. This is h, this is k, and my radius is r. And I have my formula, x minus h squared plus y minus k squared equals r squared. Let's just plug in the numbers. So this is going to be x minus 0 squared plus y minus a -1 squared equals 8 squared. And let's clean that up a little bit. X minus 0 squared is just x squared. Y minus a -1 is y plus 1 squared. And 8 squared is 64. So that's the equation of a circle that has a center at 0, -1, and a radius of 8. Example number 2. This circle has a center at -5, 3, and passes through the point 1, -4. Sometimes it might be a little bit easier to kind of do just a little sketch on the graph to see what it looks like. So its center is at -5, 3, and it passes through the point 1, -4. So this is going to be my center, okay, and actually let me erase that, and this is going to be my radius here. That's my radius, and my center is -5, 3, but I don't know what my radius is. Okay, well, let's go ahead and label. So this is h and this is k, so I can actually start my formula here. So x minus h squared plus y minus k squared equals r squared. So I'm going to have x minus a -5 squared plus y minus 3 squared equals r squared. And I don't yet know what my radius is. So in order to find my radius, it's actually going to be the distance between these 2 points. Okay, my radius is the distance between going to be the distance between -5, 3, because that's the center, and the point 1, -4, because that's a point on the circle. That's going to be my radius. So I'm going to use the distance formula, and if you have that in your calculator, you can go ahead and do that. And I get that that radius is equal to the square root of 85. So I can erase r squared and put in the square root of 85 squared. So my final answer, cleaning that up a little bit, x plus 5 squared plus y minus 3 squared equals 85. Because x minus a -5 is x plus 5, the square root of 85 squared is 85. Next example, very similar, pretty much a picture. Again, here is my radius. This is my center. So 3 is h, 4 is k. And again, I'm going to use the distance formula. Oops. On 0, -6. And 3, -4. And when I do that, I get that my radius is the square root of 13. And plugging those into the formula, x minus h, which is 3, plus y minus k is going to give me a y plus 4 equals my radius squared, which is 13. Okay, here's a few more examples. For each circle with a given equation, state the center and the radius and then graph. So now we're going to be doing it backwards. Instead of being given the center and the radius and then writing the equation, we're given the equation and then we have to graph. So looking at this, actually I'll stay here. So I have x minus h. So h is equal to 2. And then y minus k. There is nothing there, so that's just a 0. My radius is going to be the square root of 9. So my radius is going to be 3. So my center is actually the point 2, 0. And my radius equals 3. And let's graph that. So the point 2, 0 is right there. That's my center. Now my radius is 3. So to do that, I'm going to go 3 units to the right, 3 units up, 3 units to the left, 3 units down. And those are points on my circle, and then kind of connect them. And this is what I'm not very good at. And there's your graph of the circle. Okay? Key thing is to get that center and then a point north, south, east, and west. And then graph your circle from that. Okay, this is actually, it may not look like it, but this actually is the equation of a circle. It's just in a different form. Key thing is it has an x squared and it has a y squared. But it's not in the form x minus h squared plus y minus k squared equals r squared. But we can put it into that form. And to do that, we're going to use something you learned last year in Algebra 1 called completing the square. So I'm going to write x squared minus 6x, and I'm going to leave a space. And I'm going to write y squared plus 4y, leave a space, equals 3. So what I need to do is turn this x squared minus 6x into a perfect square trinomial so that I can factor it into something in parentheses squared. And the same thing with the y squared plus 4y. I need to turn this into a perfect square trinomial so that I can factor it into something in parentheses squared. And if you recall from Algebra 1, the way to do that is to take half of this number in the middle and square it. So half of negative 6 is negative 3. Squaring that gives me a 9. So I need to add a 9 here. So this is now a perfect square trinomial that can be factored. But I added a 9 to my equation here, so I need to add a 9 over here. Let's do the same thing with the y's. Take half of 4, which is 2, square it, which is 4, and add that here. And I need to add it on the right-hand side of the equal sign as well. Now let's go back to our x's. X squared minus 6x plus 9 factors into x minus 3 squared. In other words, it's half of this goes into here, or you can think of it as the square root of 9 goes into there with a minus squared. Y squared plus 4y plus 4 factors into y plus 2 squared. And then 3 plus 9 plus 4 is 16. There's the equation of my circle. My center is 3, negative 2. And my radius is equal to 4. So graphing that, the point 3, negative 2. And my radius is 4, so I need to go 4 to the right, 4 up, 4 to the left, and 4 down, and then sketch the circle down that. Okay, and the last set of problems we're going to take a look at here involves finding the point of intersection, if there is any at all, between each circle and the given line. So if you have a circle, a line can intersect that circle in 2 points. A line could intersect that circle in 1 point, as we saw in a couple sections ago, the point of tangency, or the line could never intersect the circle. So basically what we're going to be doing here is solving a system of equations. I have an equation that's the equation of the circle, and then I have another equation that's the equation of the line. When I solve that system, if I get two answers, I know that it will intersect in 2 points. If I get one answer, it will be a tangent line, and if I get no solution, then the line is completely outside the circle. To do this, we're going to use substitution. So I have x squared plus y squared equals 2. That's my circle. And then I have y equals negative x plus 2. That's my line. Since y is equal to negative x plus 2, I'm going to substitute that into the first equation for y. So that's going to give me x squared plus x minus 2, or I'm sorry, negative x plus 2 squared, and that equals 2. So I just took what y equaled, which was negative x plus 2, and substituted into my first equation for y. So x squared plus, now foiling this, so that's negative x plus 2 times negative x plus 2, gives me an x squared minus 4x plus 4, and that equals 2. And I'm noticing that I have my x squareds are not going to cancel each other out because they're on the same side of the equal sign and both are positive. So I need to combine those. That's 2x squared. And this is a quadratic equation, so I need to make it equal 0. Minus 4x, and then subtracting the 2 from both sides gives me a plus 2, and that equals 0. So before I try to solve this, before I try to factor it or anything, I notice I can divide everything by 2. So that's going to give me x squared minus 2x plus 1 equals 0. And that actually factors into x minus 1 squared, because that is also a perfect square trinomial. So solving that, x is equal to 1. So I only ended up with one solution, so I think we're going to have the case here where we have a circle and a tangent line with only one point. But I'm only halfway there because I need to find that point where they intersect. I know the x-coordinate of that point is 1, so I'm going to substitute 1 back into here for x, and that will give me my y. So y equals negative 1 plus 2, or y is equal to 1. So this circle and line intersect in one point, and that point is the point 1, 1. And let's take a look at our last example here. I have the circle x plus 3 squared plus y squared equals 25, and the line y equals negative 3x. Again, I'm going to use substitution. This is what y equals, and it's going to get plugged into here for y. And I'm going to actually FOIL this out, multiply out x plus 3 squared. And when I do that, I get x squared plus 6x plus 9. And then when I do negative 3x squared, I'm going to do it over here. Negative 3x squared gives me 9x squared equals 25. And again, I notice I have a quadratic equation because I have x squareds in it, so let's combine those like terms. That's going to give me 10x squared plus 6x, and then I'm going to subtract my 25 from both sides, and that gives me a negative 16, which equals 0. Again, I notice that this can be divided by 2, so I'm going to go ahead and do that because it's a little easier to deal with smaller numbers. I think this one might actually be factorable, but I'm just going to use the quadratic formula in my calculator. And when I do that, I get that x equals 1 and x equals a negative 1.6. In this case, I get two answers. Now, don't throw out the negative 1.6, because remember, that does not represent a distance or a length of a segment. That's a point on the coordinate plane. Now, to find my corresponding y values, I'm going to take each one of those and plug them back into here. I have two x's. I should end up with two y's. So y is equal to negative 3 times 1, or y is equal to negative 3. And that corresponds to 1. So one of my points is going to be 1, negative 3. And then plugging in negative 1.6. Y is equal to 4.8, and that's going to give me the point negative 1.6, comma 4.8. So this is a case where the line intersects the circle in 2 points. So in this lesson, we learned about the equation of a circle, which you'll need to memorize, how to find its center and radius and how to graph it, and then how to write equations of circles and how to solve systems of equations that involve a circle and a line.